Alright, this video is meant for you to be doing your homework right alongside with me and right alongside with your textbook. I'm going to just be reading the problems from the textbook and writing some things down, and you should either have it already complete and be checking your answers or be working right alongside me. So in number 3, you're given a couple of ordered pairs, 3, 0 and 3, 5, and you're asked, can they represent a function? No, because of the definition of a function, each item of the domain may match with only one item in the range, and this 3 obviously has 2 matches. In number 5, f of x equals the square root of 1 plus x, and they want to know if x equals negative 2 is part of the domain. And so if you were to substitute negative 2 in there, you'd be taking the square root of negative 1, which we already know about imaginary numbers, but no, as a general rule, we do not allow for the square rooting of a negative number. In number 9, you're given a series of baseball teams, and we see that in the National League, we have 3 different teams. So the National League would be an item of the domain, and then it's got 3 possible choices in the range, and then the American League has also 3 possible choices. So because each item of a domain automatically matches with more than one item in the range, then no, it is not a function. In number 17, we are confronted with an equation, and we want to know if it is a function. So in number 17, not sure if you've studied circles or the equation of a circle, but I just covered that in my geometry classes, so I'm going to say yes. So this is the equation of a circle with a center at 0, 0 and a radius of 2. But, so visualizing the graph of that, I can see that it fails the vertical line test, so I know that it's not a function. I could see that if I plugged in two for x, 0 for y, let's see, at 2 for x, that is actually one spot. Tell you what, rather than trying to visualize or pick different values for x, let me go ahead and solve for y. So y squared equals 4 minus x squared, and the square root of both sides, so y equals the square root of 4 minus x squared. So the fact that when I take a square root I have a positive and a negative, that means that I'm going to have more than one item of the range for certain items in the domain. In number 19, I am looking at y equals the square root of x squared minus 1. And knowing what I know about the graph of this, I'm going to see that if I have, well, 0 is not in the domain of this function, so the domain starts at 1, and when x is 1, y is 0. When x is 2, I get the square root of 3. So this is going to follow that square root curve, and so that's going to follow the, it'll pass the vertical line test if I visualize it. Now, of course, you could graph it on a graphing calculator if you're not that good at graphing yet, or I can make a table of values and substitute different values, or I can recognize that I don't have this plus or minus in front of it. I'm just looking for the positive values, so each and every item in the domain is going to match with one item of the range. In number 21, my equation is 2x plus 3y equals 4, and automatically I notice that is a linear equation in standard form, and all lines are functions because they pass, except for vertical lines, because they pass the vertical line test. So yes, that is a function. And then number 23, that one's tricky. So that kind of goes back to the whole plus or minus square root. If I want y by itself, I've got to square root both sides, and if I'm taking a square root of both sides, I have to have that plus or minus symbol, which is going to mean that I'm going to have more than one item in the domain for each and every item of the range, so that is not a function. For number 31, the instructions say evaluate the function at each specified value. So my function is h of t, and h of t equals t squared minus 2t, and we're looking for h of 2, h of 1.5, and h of x plus 2. So when we do h of 2, we're going to substitute a 2 everywhere that we saw a t. We're going to erase the t and replace it with a 2 inside of parentheses. And then we're going to evaluate it. So 2 squared is 4. We're going to evaluate it using the order of operations. So I'm going to do the exponent first. 4 minus, and then I'm going to do this multiplication next before I do the subtraction. So 4 minus 4, and then work out the math, and that's going to be 0. When I substitute a 1.5, I'm going to do the same rule of substitution. I'm going to erase all of my t and replace it with the number inside of parentheses. And then I'm going to evaluate it using the order of operations. So 1.5 squared, do my exponents first, and then I have to do multiplication before subtraction. So now I may do the subtraction, and I get negative 0.75. Then part C is more the Algebra 2 or pre-calculus level. So I'm going to erase the t, and I'm going to substitute an x plus 2. And then I'm going to evaluate the exponent first. And remember, now let me write it over here, x plus 2 squared, I can expand it out, and that way I'm less likely to lose a middle term there. So I'm going to do double distribution, so I get x squared plus 2x plus 4. And then I'm going to distribute here minus 2x minus 4. So now I've got a large combined like terms problem, and I can cancel some things out. Here 2x minus 2x equals 0, 4 minus 4 equals 0. So I am left with x squared plus 2x as my solution in number 31. For number 33, my function f of y equals 3 minus the square root of y, and I want to evaluate f of 4. And f of 0.25, which is 1/4, and then f of 4x squared. And remember, when we substitute, we're going to erase our y and replace it with the value. So 3 minus square root of 4 is 2, and that's treated as an exponent. So I'm going to work that first, and I get 1. And then 3 minus square root of a 4th. The square root of a 4th, you can use your calculator or just in your head, you know 1/2 times 1/2 is a 4th, so that's the square root. So I get 2.5 or 5/2 or 2.5 for that one. Then substituting in a 4x squared. And the square root of 4x squared is 2x. So 3 minus 2x. And then for number 33, so you've got a couple of different ways to deal with that. Whenever we take a square root, if it's not somewhere specified that they only want the positive part of it, we need to take into account that that x is going to either be positive or negative. So we can call it the absolute value is one way to write it, or minus 2 times positive x is minus 2x. Minus 2 times negative x would be plus 2x. So you could do a plus or minus type symbol right there. And that would suffice as well. Alright, number 37, our function. Let me start a new piece of paper. Okay, number 37, our function is the f of x is the absolute value of x over x, and the three values that I want are f of 9, f of negative 9, and f of t. So f of 9 is absolute value of 9 over 9, which is 1. F of negative 9 is absolute value of negative 9 over 9, which is 1. F of t is absolute value of t over t. Oh, I made a mistake here. I was going to try to simplify that into a 1, but sometimes it's a 1, sometimes it's a negative 1, so I really can't go any further. So that's as far as that one can go. Number, what's next, 49? In number 49, we're given a function h of t, and we need to fill in this table. So I'm just going to go ahead and copy it real quick. We need to plug in negative 5, negative 4, negative 3, negative 2, negative 1. So 1/2 negative 5 plus 3. So that's going to be half of negative 2. Half of the absolute value of negative 2, which is half of 2 equals a 1. Then to do negative 4, that's 1/2 of negative 1. Half of 1 is a half. Negative 3, half of 0 is 0. So once you discover the pattern, you could probably give yourself a shortcut, but I just don't ever do that. So negative 2 plus 3 is positive 1, half of 1 is a half, and then half of negative 1 plus 3, half of 2 is 1. Okay, so we know that absolute value equations kind of, when we graph them, have that V shape. So that's why it goes down and then back up again. Alright, next is number 53, and I'm going to run out of time. So let's see. F of x equals 3x minus 4 divided by 5, and the directions say I want to know when is f of x 0. So I'm going to substitute a 0 over here on this side and then solve. So I'm going to multiply by 5 on both sides. I get 0 equals 3x minus 4, add 4, 4 equals 3x.